Hey everyone! I'd like to show you the new Promises library that we made here at Roku Community. This is a brand new way of writing async workflows on the Roku platform in BrightScript and BrightScript. So we modeled the library after JavaScript promises, but there are a few differences that we'll explain a little bit later on. So first off, I want to explain why we wrote this library. Writing multi-step asynchronous code on Roku is hard. Typically, you have to observe a field on a task or a node, and then you have to write a named callback function that it will call when the field changes. And that's just for one hop. If you have more asynchronous tasks that need to be fired right after that, you have to kind of repeat the same process, which can quickly lead to a tangled mess of callback dependencies, nested functions. And if you've got multiple network tasks that need to run one at a time, it adds even more complexity. Promises can significantly improve this entire workflow. It improves the maintainability and readability of these flows. So let's get into it. So first off, I just wanted to show you where you can get access to the Roku Community Promises library. It's out on our GitHub page. There's a repository called Promises. And we have a few installation instructions that you can follow depending on how you want to do it. If you wanted to use RoPM, or you can do manual install, and you just need to follow the instructions here. We also go into a little bit more detail as to how promises are set up, what they look like under the hood. We'll get into that a little bit later, but I just mostly wanted to point out that this is where you get them. So let's go ahead and switch to a demo project. It's a pretty simple demo. It just shows a series of dialog boxes, one after another. So the first one makes the user choose a movie. And then the next dialog asks them how they want to pay for it. And then a final dialog saying, congratulations, you made choices. This is a great example of an asynchronous workflow. So let's take a look at how it works right now in regular Roku BrightScript. So the main scene run movie plan selection. So the first thing we do is we call the show dialog function, which this is just a quick little function I wrote that wires up a new standard message dialog, observes the button, and then sets a custom field based on what the user chooses. So we're going to have a user pick a movie from one of these options, and then set the result of that button value to the m.top.selected movie field. And that's why we're observing this. So the flow goes, show this dialog. When they choose it, set this property, which will fire this observer, which then runs this code. And we then want to ask the next question. So we're going to observe the selected plan field. We're going to ask the user to choose a plan. It'll set it to selected plan. And when that plan changes, we get called back on the onPlanSelected function right here. And then we show the final dialog saying, congratulations, you selected something. So on its own, this isn't too complicated, but as you well know, these flows can get really, really complicated really quickly. You know, a lot of the time you end up seeing these functions kind of trickle down throughout the code. It gets to be a bit verbose and a bit broken up. Let's put those back. So what I'd like to do is show you how to refactor this to use promises. So I think the easiest approach here is to first show you how the promise flow is supposed to work utilizing promise chain. And then we can modify show dialog to actually return a promise. So we know we're not going to be using observers, so I'm going to go ahead and remove all of those. And show dialog will eventually return a promise. So we're going to say movie promise. And then the magic happens here in promises.chain. I'm going to pass in movie promise. And whatever the result of movie promise is, will be passed in as this first parameter for the .then. And so what we want to do is we want to handle when we get the movie back, which is actually this content. And in this case, it's going to be movie. Then the next thing we need to do is get the plan. So this will be plan promise. And we're going to return it. Because the way promise flows work, whatever gets returned from the .then, if that's a promise, we'll actually wait for that promise before we call the next flow. So we got another then, And then that will be the internals of the onPlan selected right there. So we can actually scrap these functions entirely. m.plan equals, oops, that should be called plan. And then let's just do one more then. And we're not actually going to use this, and we'll just call it underscore. That's fine. So we've successfully converted our promise chain, our asynchronous flow into a promise chain. Now notice I didn't need separate named functions or observers for this. We could actually even eliminate the observer logic from all of this because we're not going to be using those. So we can delete the field name. We can delete the field name parameter there. We're not even going to do anything with the field name. We don't need to observe. That one will leave. So next up, we need to make this actually work with promises. So we'll call this m.custom.dialog promise equals promises create. This makes a new promise. And then we return it here. Then the last piece to tie this all together is our selected button down here. We have to resolve our promise with that value. So promises resolve. We'll put the value in there, selected button, and then m.custom.dialog promise, because that's the promise that we're resolving. So by doing that, this entire async flow has been reduced to these nice, easy to digest, sequential looking blocks of code. So let's go ahead and run it and see what happens. There we go. There's the first one. I'll make this a little bigger. Boom. It works. So there you have it. One really cool thing about promises as well is they have additional error handling, and I don't care if it errored or succeeded, but I need to know when it is done flows. So let's introduce an exception in here. Let's just throw something. Something went wrong. And let that crash. And now we can do a .catch. You can print E. So you can actually try catch using these .catch promise chain functions to help catch errors in your asynchronous flows and recover. And this allows you to also do a .then after that. So let's run it again and see what we get in our output. So first time, I'm going to say OK. And boom, something crashed. And look at that, we recovered. Do something smart here. So that will allow you to handle errors in your asynchronous flows, which is incredibly, incredibly useful. Next, I want to talk about how we can pass state through these promise callbacks. So in JavaScript, for example, you could just directly access this variable because they have support for closures. But BrightScript does not. So this function can't see any variables found outside of it. To get around that, we support a second argument to promise chain called context. I'll go right here. Now this can be anything you want. It can be a primitive. It could be M. But for now, we're going to pass a separate associative array called state through that. And once you've done that, you need to make sure all of your promise callbacks also have that second parameter. Because of the nature of the BrightScript runtime, you'll have argument mismatches if you're missing this. So make sure that once you pass 2 arguments to promises chain, you have 2 parameters. Now, if you don't want to use it, you could always just do something like an underscore or some way to denote that it's optional. So now that we've got state there, we're going to convert all of these to state, and you'll notice that this will flow through. And it's the same instance, by the way. Unlike putting this as a field on the promise, we actually store this state on like a private, secret, obscure M variable. So this object never leaves the current scope. So as you flow through, it's the same exact instance. You can put like regular expressions on here, row regex, or row datetime, or even like a function. And these won't get stripped off because it never passes through the node boundary. It's incredibly powerful. It makes it really flexible for storing anything you need on state without having to put it on M. So I'm sure you're wondering how a promise is actually set up. What does it look like under the hood? I'm not going to get into too much detail. The entire project is available on GitHub, but I'll give you a quick overview. The main core component is called promise, and it has a field called promise state. And one of the reasons for this having the word promise on it, even though it's named promise, is because we wanted to prevent falsely identifying any other node that might have a field called state on it. So the fields are called promise state and promise result. Now notice we don't have a field called promise result on here, and that's because we don't actually know what the type of your field will be until the promise has been resolved. So promise result will exist when the promise resolves, but it will only be added using the update function once the promise resolves or rejects. So all promises have a promise state, and they will have a value of either resolved, rejected, or pending. And as you observe these promises, if you're ever interested in writing your own promise library, this is the field you want to observe. That way you don't spend extra time serializing and deserializing whatever result goes in here. So we highly recommend that you use our promise library, but the idea is we really wanted promises to be compatible on a specification level. So no matter what library uses promises or creates promises, you should be able to interact with a promise from any library, as long as it conforms to this design. So I wanted to briefly mention a few other things. The first is that you can use promises all to wait for multiple promises to finish, and you get a callback when they're all done or if any one of them had errored. So this is great for running requests in parallel, as an example. So here is a quick code example. So there's a magic HTTP function that does a bunch of stuff, and I'm just going to paste some of the stuff in. So you're doing 3 requests to Alpha, Beta, and Charlie, and we want to wait for all of them to finish, but they're all running at the same time. So you can use promises chain to wait for the promises all call. And then when you get the callback, all 3 of them are done. Super awesome. Another thing you can do is you can use promises to observe user input, like, are you still watching? Press any key to resume. They're good for timer callbacks. Like here's another example where you could do that. Well, maybe you have a function called sleep promise that lets you sleep for 3 seconds. And when that's done, then you want to run some code. Since promises are nodes, you can actually share them between components. For example, if you wanted to make a request as soon as possible, but the UI isn't ready yet, you could make a UI is ready promise and chain your setup logic to run after it resolves. They're also great for resolving race conditions where you're not sure which one's going to fire first. There's a ton of other ways you can use promises, but I want to point out that they're not just for tasks. They're for anything asynchronous. A good example would be our dialogue demo from earlier. That actually didn't enter a task thread at all. That was all done in the render thread. So promises are great to be used in the render thread and the task thread in terms of creating promises. But just to note, you can't use promise callbacks and promise chaining in task threads. And the reason is task threads mostly depend on while loops and message ports, and we don't have any support for that yet. And it gets a little weird because we don't have like the standard event loop sort of thing that happens on the render thread. So I hope that you found this interesting. I hope that you can find a way to use promises in your own projects, because we have found them super useful in the projects that I've worked on, and I hope this can help to revolutionize your workflows. Thanks.